So since Håkon asked me to do the presentation this morning, so I apologize that probably I would not be able to give you really all the information about the experiment, all the statistics. But okay, so if you have some questions, then come back and we will contact Wojtek. Good. So this is the list of the basically science team, the people who were working on the instrument in the beginning, calibrations and different kind of technical things, but not really making screws, and those who are making science till now, and of course VMC engineering team. We have really to give credit the people, and I think that the next slide. To the people who has made the instrument and really who were doing the lots of work on the hardware in very quick manner. So the idea of VMC came when we were discussing Venus Express and basically we understood that the cameras which were available from Mars Express or Rosetta will not suit the mission at Venus because simply we did not need such sophisticated instruments. So that's why we decided, okay, let's try to do a small webcam which will fit some science goals. So ESA was actually against that because they said that no new experiments should be there. So we started our experiment with the acronym, with VMC, because on Mars Express there was a visual monitoring camera. And we said, okay, look, there is some camera, some webcam. We just want to adjust this to the Venus needs. ESA agreed. So this was some trick because no camera existed, but it worked. So the idea of that, now I can tell that. So, so the idea of that camera, of course it was not like this, but it was about that. So the idea of that camera was really to make a very simple, very small instrument, but to have very clever filters on that. To put 4 filters in UV, in the visible, and 2 in the near infrared, which will target certain goals at the planet. UV, you know, this should be centered at the UV absorber, 365. Here are the parameters of those cameras. Infrared, this is where we wanted to look at the surface, etc., and a couple of other filters in between. So if you look in the eyes of the camera, you would see such a beast with 4 eyes. Each of those is a narrow band filter, which were focusing on the same CCD. Basically, CCD of 1K by 1K was divided in 4 quadrants. In each quadrant, you got the images like this. This is UV, visible, infrared, and this is infrared on the night side. Good. So this is the instrument being assembled by the gentle hands of Ilse Sebastian, who was one of the main engineers at the Max Planck at that time. And just to say that the VMC was designed and manufactured by a consortium of German institutions, MPS, Max Planck Institute, then IPF, DLR in Berlin, and IDA in Braunschweig. It was really kamikaze and very quick project because everywhere there was a deficit in manpower. And, but we managed somehow to put everything together very quickly, very dirty, but it worked, you will see. So these are the images, and we got lots of help from our Russian colleagues. Basically, thank you very much, and thanks Iki, who sent really young guys who worked day and night on the technical issues, on calibration, on tests of the instrument. And I was at the time given an honor to put the final, to close the flight instruments and to tighten the final screw here. And yes, and we, after that, we made a photo. Well, unfortunately, it's not seen here, but okay. So we discussed who will be the first person to film by VMC. So, and of course, this, like in Germany, said Versuchskaninchen, or the test rabbit was the PI. So we decided, Wojtek, please stand in front of us, in front of VMC. And so here you see Wojtek in UV, in the near infrared, again in the near infrared, in the visible. Well, the image is there, simply here it's overexposed. So this is basically funny, but this is how the Venus looked like in our VMC shots. So we have 4 images in one go. Of course, we have to sort them out. Some of them were thrown away because the exposures were too high and they were overexposed. But this is the process. All these strips here, it's exactly what we had to calibrate out. So this is the inhomogeneities of the flat field. This was done, and of course the dark current was removed and all other things. We used the calibration looking at the stars. So basically the final products which you can find now in the Planetary Science Archive are the calibrated, absolutely calibrated images in the UV, visible and infrared. So after several months of cruise, we got the first light, and it was complete shock for all the team, because this is definitely what we did not expect. This is how the VMC images look like, and well, after a couple of days we understood that simply the detector was burned by the sun. It's not that we were stupid. We understood that we knew that the spacecraft will be flying in such a way that it will look at the sun with the VMC, with VMC. But we hoped, and actually we made a lot of calculations and even the tests in the lab, that since the filters are very small, the lenses are very small, the filters are very narrow, it will not be too much energy inside the instrument. So that's why we said, okay, no problem, we do not need a shutter. Well, with the shutter it would have been a problem anyway, because it was really very, schedule was very, very tight. So, and mechanically, to use mechanics, you know, it's always a headache. So that's why we decided to do that, and we got this result. It was almost really a shock for everyone, as I said, so we decided probably we have to close the instrument. But then after thinking, we said, okay, we have a calibration body just in front of us, Venus. And the polar cap and polar regions, they're very homogeneous. Let's look at them and use them for flat fielding. And after this smart procedure, we got these images like this. So basically we managed to remove all these inhomogeneities in the flat field, which we got due to the solar illumination, and to remove this garbage and getting the images which are not excellent, but quite good and, well, relatively, we can do science with them. And so now I will turn to, yes, before going to science, so this was the orbit of Venus Express, and the ideology of VMC was to take images like this when we are in apocenter. This is the image exactly from the apocenter. Then a sweet spot in orbit when we're about 10,000 kilometers from the planet, when the planet is exactly in the field of view of VMC. When we are flying at the pericenter, we're getting very close-up images with 100 meters per pixel resolution, and so on. Good. So I will run through several scientific topics and show you examples of the results. First of all, cloud top morphology, especially in UV, when we have this 365 nanometer filter. So we see all these famous UV markings which are created by famous and unknown UV absorber. And so we could have the images of the whole planet, like here, and we were observing the planet which was changing every day just in front of us. The morphology structure, the size of the polar cap of this polar haze, everything was changes every day, and it was really fun to look every day at the arriving images. Coming closer, we could see the images with mesoscale features. This here and on the next slide. This one is focusing on the polar region. Everywhere the South Pole is somewhere here in the lower right, and you see how the polar cap is changing from one orbit to another. Again, mesoscale features with lots of waves at the cloud tops, and this is the subsolar region with lots of bow waves with different kind of trains, etc., with fronts which we see. Very nicely and very nice, I showed already in my first talk, and close-up images in the polar regions, which when we are very close, this is about 200 kilometers bar here, and especially the polar waves which were discovered, and it was really very nicely seen in the VMC images. And probably here, this is the global view from Sanjay, a very nice similarity between Earth cyclones, and this is the image of the Earth cyclone, and morphology of the Venus polar cycle. The southern pole is sitting here, and this is the reconstructed morphology in the Venus southern hemisphere. Good, so this was the morphology of the cloud top due to UV imaging. So what you see here and what you saw in the previous slides, this is inhomogeneous distribution of the unknown UV absorber. Well, the motion of those clouds, since we were taking images in a sequence, say one image in half an hour, we could really reconstruct nicely the motion of the clouds. I do not show a movie here, but instead I will show you the profiles of the zonal wind. This is the black curve here, and meridional wind, the black curve here again, which is overplotted on all the experiments which were available before, on Mariner 10, Pioneer Venus, Galileo, and Vex Virtis. So basically, VMC results here are represented by the dark solid line. And our colleagues in Moscow, they used those images, and it was really titanic work, so they reconstructed about 500,000 of vectors, of wind vectors, using the manual tracking, using the digital tracking, so that was really very nice database of wind field. Also, we saw how the wind profiles, again, this is the latitude and this is the wind speed, this is zonal wind, how they're changing from orbit to orbit. This is the orbit number, and you see from orbit to orbit, you see changes in the dynamics, in the latitudinal profile of the zonal wind. Now, interesting result came out when you take about 20 plus minus 5 degrees latitude zone, and you try to see how the winds were evolving during the Venus Express mission. And this is what we got. So in the beginning, on the left side were the Galileo, Mariner, Pioneer, Venus zonal winds, which are shown here. And these are the data from VMC. And surprisingly, we were tracking that, and we were seeing how the winds are increasing. Where do they stop? So that was the question, because it was over the several years. Probably this is not Venusian year. I think that is the Earth year. No, it's Venusian year. Yeah. Interestingly, first we stated, okay, we see acceleration of winds over a significant portion of the time, of a decade. So where does it come from? But then recent research showed actually that what happened, that the observations in different seasons were taken above different topography features. And actually this increase, it seems that it's correlated with topography and Aphrodite Terra, which is at about 20 degrees south. It really produces this effect. And now one paper is in preparation on this, and I think it's very nice finding. So it's not really acceleration of the winds, but basically this is related to the surface topography. Okay, another result, diurnal variations. So this is what we see for the zonal wind. We see that the winds are maximum in the afternoon, in the low latitudes. For meridional wind, the winds are maximum also in the afternoon. Then interesting results, which you can see on the poster here, is the tracking of the infrared features. What I told before in these slides before, this was the UV features were tracked on the cloud top at approximately 70 kilometers. Now Igor Khatuntsev and Marina Patsaeva-Teki, they are working with the infrared features, which have much lower contrast, say about 3–4%, but still you can see the features, you can track the features. So these are the first results, in which you can see in the poster number 19 here. Another result, this is from Arianna Picciali. We looked at the polar waves, which we see from time to time, and relatively frequent appearance of those polar waves. And we plotted them on the topography with different crosses of different colors here. Simply different kind of waves are plotted with different colors. And we found that these kind of waves are associated with Maxwell Mons and with Ishtar Terra. So that was also interesting. Correlation. It's just correlation. We still do not understand how to explain that, but most of the waves we see in this region. Okay, there were glories observed on the cloud top, and here you see the glories. Basically, the sun is just on the back of the image, and you're looking in nadir. And from these glories, the particle properties were derived, and I think that one of the conclusions was that yes, you need, in addition to sulfuric acid, you need some kind of different material to increase the refractive index. Because with the refractive index of sulfuric acid, it was not possible to explain the brightness profile across this glory. Good. Surface observations. As I said, 1 micron image, 1 micron filter, it pointed to the transparency window, which allowed to look exactly at the surface. And what we expected, this is the Magellan map. Usually when you have this kind of thermal emission which is coming from the surface and manage to escape through these thick clouds, what you expect that the lowlands here will be higher than the highlands, and the difference in temperature is about 40 degrees, and it's significant, and you should see brighter areas here and darker areas here in the mountains. And this is how the VMC mosaic looks like. So basically, yes, you can see all the features on the surface. And these features are mainly explained by the differences in topography and differences in temperature. But not all of them. Like for Virtis, there were some emissivity anomalies which were found in the VMC images. They were analyzed, and there were some conclusions about some regions which are younger than the other ones, meaning that they could be, that possibly there is regions of recent volcanic eruptions, recent in geological sense. But there was a nice observation. We tried to look at the images flying over the same place. We tried to look at the images at different time. And especially above this Ganiki Chasma. These are the images taken on June 22nd, 24th, and October 13th. And one interesting spot was found that it was almost no emission coming out. Then it was on June 24, it was pretty bright, and then it disappeared again. So this was interpreted like the really that we found and we saw the eruption of volcano and lava flows just at that time, happening at that time, and then this disappeared after a month or so. So this was a couple of events like this were found, and the paper was published, and I think it's really interesting, interesting discovery. Good. A couple of interesting things which are still not yet analyzed and not yet understood. As I said, we have visible filter centered at 513 nanometers. And when we looked on the night side, in principle, we did not expect to see anything in this filter. But then on the night side, the planet is here, the space is here, but at the limb, we see a bright crescent. And this is basically, when I looked at that, I saw that this is exactly in one of the peaks of the emission. In the spectrum of Venus and airglow emission, and it seems that yes, the VMC with VMC we can map the airglow emission in the visible channel. But again, so these data are there, but no one has analyzed or published that. And another interesting thing that we're all saying that yes, we have UV. And we have lots of contrasts, lots of features in the UV, but then when we go to the visible, they disappear. Well, in principle, that's what one expects. But look here, the southern pole is approximately here. This oval, dark oval, was always observed in the polar regions. And this is the UV image. But when you go to simultaneously taken visible image, everything disappeared except for this dark oval. So meaning that there should be some species which also absorbs at visible wavelengths, and that's why I spoke yesterday with Bob Carlson when he was talking about these allotropic forms of sulfur which has extended absorption in visible wavelengths. So that's what is exactly needed here, because with the usual sulfur you should not get the absorption at beyond the 500 nanometers. Okay, a very brief summary. So despite of we had really damages and lots of nerves was spent on this damage of the detector, we have excellent science from atmosphere to the surface. And the science team continues with data exploitation. People are still working on the data, but of course new ideas and interest are always welcome. And please contact either me, Wojtek, or other members of the team. And of course the images, the full set of calibrated images is now available via PSA. So we are on the archive, and so you can find images plus documentation there. And I think that the last slide, even we made VMC image made in the space science at Royal Mail. So this is one of the
first class
post. Okay, good. So I stop here and ready to take your questions. Mm-hmm.